Are you looking to harness the potential of data-driven modeling for industrial processes? This unit is designed to help you to unlock the secrets of creating digital twins of complex dynamic systems. Artificial neural network is a good tool for data-driven modeling of industrial systems. They help to design digital twins of processes by learning from data and replicating the models of complex processes. They are capable of learning both statics and dynamics of the system. Neural networks-based models can be used for prediction and control of industrial processes, as well as predictive maintenance of technical systems and devices. Today, let's step into the future of industrial processes with artificial neural networks. In this presentation, we will discuss how artificial neural networks can be used for data-driven modeling of industrial processes to create digital twins of complex processes. First of all, we will answer the question, why do we need to model industrial processes? Then, the meaning of a dynamic process will be explained. What dynamics means from a mathematical point of view, how dynamics influence choice of the neural network structure and data pre-processing. Main steps of identification procedure will be explained. Both feed-forward and feedback structures of neural networks will be explained. We will also discuss main benefits and drawbacks of using neural networks for identification of dynamic processes. When working with industrial processes, we often face the problem of modeling the process. So why do we need to model the industrial processes? There are several reasons for that. First of all, in order to understand some physical phenomena of the process. Second, in order to predict the behavior of the system in different situations. For example, in case of different environmental conditions or in presence of disturbances. Third, in order to control or optimize the system. In some applications, not the model directly, but predictions made by the model are used to control the system. The majority of industrial processes are so-called dynamic systems. It means that their reactions to certain inputs depend not only on the values of these inputs, but also on the state of the system. In other words, systems can react to the same input in a different way in different situations, called states. To model such processes, a dynamic model is needed. In mathematics, a dynamic model is represented by a differential equation. As soon as the process becomes more complex and nonlinear, classical linear methods stop working. Analytical nonlinear approaches are getting too complex. Machine learning and AI methods, for example artificial neural networks, can be a good choice of a tool to model complex processes based on collected input-output data. In general, neural network-based identification of any industrial process can be formalized using the following steps. First of all, getting experimental training data. Input signal is given to the system and the corresponding output reaction is measured. Obtained input-output data is used to train a neural network-based model. Then, choosing a proper neural network structure, number of inputs, outputs, hidden layers, neurons, activation functions. After that, choosing initial weighting coefficients, usually random. Now we can calculate neural network outputs corresponding to the training input sets. Then compare that outputs with the reference outputs from the training set. In other words, calculate the error of the model. Finally, calculate updated weighting coefficients using selected training algorithm and repeat the last three steps. In order to model dynamic processes, neural network representing the structure of the model should also include dynamics. That means feedback or inner states. There are two approaches to implement dynamics in the NN-based model: internal or external feedback. In case of external feedback, neural network itself is static, feed-forward, but has additional inputs representing so-called regressors, some previous inputs and outputs. In case of internal feedback, the network has as much input as the modeled process. In case of a process with one input, the model also has one input, and so on. All the feedbacks will be inside the network structure. In general, the main motivation towards applying artificial neural networks for modeling of dynamic processes is that it is simple and straightforward data-driven approach. Another benefit is that neural network consists of single nodes, neurons, and by combining them in a different way, one can easily replicate the structure of the system. One more benefit is neural network's natural ability to learn. The model can be adjusted and improved online when new data comes. The main drawback is the lack of explainability of the most black box models. This problem is now actively addressed by scientists creating so-called explainable AI, also known as XI. NN-based models are easy to use to predict the behavior of the system, but they don't provide new information about the physics of the process inside the modeled systems. It is also hard to guarantee stability of such systems, especially in case of adaptive controllers adjusting the models online. These are the main challenges addressed by the researchers nowadays. At the end of each unit, you will find several questions to test your knowledge. Here is one of the questions. Why neural network-based models are not used in some practical applications? The answer lies within the materials covered in this unit.